So I think it's good afternoon, everyone over there in Europe. I am here in the United States on the West Coast, so it's very early my time here. I'm Michael Gebretsadik, location product manager for at SS8 for our location solutions. My background has been in location technology for better part of 2 decades, primarily for telcos. I've worked as an engineer, product manager, and business development. I've deployed location platforms both for public safety and commercial services as well. Stuart?
I'd say good morning to everybody, but I think now it's good afternoon. I'm Stuart Walsh. I'm Field Product Director here at SS8. You may see a title in my up there called Creativity Software. We're a subdivision within SS8. I'm based here in London. Actually, today I'm in Kingston. And my background, my job is to support the field. So I take all of the great things that Michael does and support the sales field all around the world in all things location and data enablement. My background is in mobile networks and fixed line network, providing monitoring and OSS solutions, and look forward to speaking with you all things location today. Michael.
Yeah, and just a little bit introduction of SS8 for those not familiar with the company. We are a lawful intelligence company providing mediation and monitoring centers, monitoring function platforms for law enforcement. We've been in this industry for over 20 years. We are deployed in over 35 countries globally, and primarily an engineering organization. More than 80% of our staff is in R&D, and we are a trusted provider of location intelligence solutions across the globe. Okay. So why are we talking about location in 5G? And the primary reason is public safety, and this is now also gaining traction in Europe. It has been a FCC mandate here in the United States for again for probably close to 30 years. And especially given with how much pervasive mobile use is now across the globe, both here in the United States and in Europe, emergency calls today are primarily made from mobile phones. And we've been relying on location provided by the networks per the FCC mandates here. But really up until now, it's been a 2D position, meaning just the X and Y. And that gets put on a map, and you have some location with some level of accuracy that is provided to the public safety answering point. But now, as more and more people live in extremely dense cities, now apartments, especially in high rises, when you are making a phone call from somewhere in a 30, 40, 50-story building, just an XY does not serve the public safety, the first responders very well. A vertical positioning is also required. So this is something that the FCC has been pushing, and 5G now really addresses that need with some of the new positioning techniques that have been included in the standard that allows a Z-axis to be calculated as well.
And just to augment that point, Michael, I presented this year at the European Emergency Number Association Congress, and one of the topics I was presenting on vertical, and I know it's something that the US have actually pioneered, and the rest of the world is looking at it enviously, wondering when they're going to get it. But it is big, because after my presentation, some of the leaders in emergency services came up to me and they said, we can't get this soon enough, because when we send people, like example here, one of our customers here in London would be the London Fire Brigade, and the emergency services, which is called BT 999. but they say they might be called to a building, like a large building in the city, and they have no idea where they're going from there, and it's pure luck. If we could tell them not only that the building and the door to go in, because the guys were saying, hey, even if you could give us which side of the building to get to, but also which floors. And he said, even if you could come to 3 floors, because a lot of the time we just don't get the intelligence. We turn up and people aren't aware of the emergency sometimes in the building, and then they're having to do a lot of work before they get to it. If they're able to have this information, it will save lives. You know, we do obviously have solutions for commercial, but this will actually save lives. And I think it's something that's going to become more and more prevalent around the world. Obviously, there's a lot of standards, and that was one of the conversations I had when I was at the ENA conference was, well, how do we get there? Because the good thing about Michael and I interacting is, you know, Michael's based in the US and he's been around the location business and he knows the FCC regulations far too well, sometimes when I ask him.
Too much.
But they want to know from all around the world, whether it's the Far East, Australia, whether it's the Middle East or Asia or Africa, all of the governments and operators just want to know where's the vision with this? Where is it going to go? And it's helpful, A, to get these messages across, but also to try and help paint the picture of what's possible. Because, you know, I was amazed as I attend these conferences where they say, I thought we already had this. And then their colleagues will correct them and say, no, we don't. So it's all about getting the message out and what 5G will absolutely change. I mean, 5G, as you've seen from some of the previous presenters, is going to present amazing commercial opportunities. We'll talk a little about that, but more than anything, it could save lives. Michael?
Okay. So actually, this is I'll let you take this.
So very quickly, I just wanted to take you through the evolution of location accuracy. One thing that people take for granted, and again, we're just using the example. So here in Europe and in the UK, if you dial 112 or 999 in the UK, you know, the emergency services will learn where you are. And there's a variety of techniques that they use and they've used. And this is used not just for emergency services, used for law enforcement, it's also used for commercial services, of which we support all of these for operators and governments. But it's kind of evolved over time. Obviously, from 2G, 3G, it tended to be what we call cell level accuracy. What we mean by that is if you look at that box on the left, it's that area. That's what they can tell. And a lot of governments are still here. I was recently at a police conference here in the UK, and it was to do with mobile networks and what the mobile networks do to help the police force. And, you know, one of the senior managers said to me as I was painting her the new technology, she was saying, this is like voodoo technology because all we get today is a cell. So all I know is that the people is somewhere in that shape, in that whole shape there, it could be up to a kilometer. Obviously, we say it between 200 and 500 meters. It really is, it was painful for people. Obviously, over time, as 4G became more prevalent, techniques became available and became standardized, especially through 3GPP. And then we were able to get more down to the level of 50 and 100 meter accuracy. Still very much 2D at this point. But the whole idea was that we could actually get down to at least the street or a couple of streets. So it really started to help people. A lot of governments, a lot of organizations are still moving in this direction. They haven't moved to what we call the greater level of granularity, the greater accuracy, but it is there. 5G transforms that. As you can see in the last one, we're looking at what we call GPS level accuracy. Now, again, a lot of caveats on that because yeah, it depends where you are, depends on the cell density, the frequencies that you're using, and the generations, intergenerations you're using. Sorry, Michael, go ahead.
No, please continue.
So as you can see, 5G will get you right down to a particular spot. And it's being able to combine everything that the handset does today. So in the future, you know, the plan, the whole evolution would be that when you dial 112 or 999 or 911, the phone will be augmented by both where it knows its location through GPS or Wi-Fi, and what we see more prevalent and what we're talking about today, the network will know where it is from an emergency perspective. Now, don't worry, it's only done for emergency. Whole GDPR and anonymization services still take place, but it means that there will be a real revolution as opposed to an evolution. I know I've said evolution up on the title, but I think once these things start to bed in, we'll start seeing such significance that it will transport many things from the metaverse. We were talking about that earlier, saying metaverse was indoors, but actually, it's both possible to have it as augmented reality and so forth, and being able to do that in real time with real level accuracy will actually be key. So it's not just for for emergency services. You can see how it will help commercial services as well. So I think next slide.
Yeah, and just before we jump on to, I wanted to emphasize this is kind of the area that where the FCC has really forced the issue. Going back to the 2G networks, the mandates they had, it was separated between handset-based solutions and network-based solutions, and understanding that the network-based solutions had very poor accuracy. And they used to break down the accuracy requirements in a kind of in a 1 and 2 sigma groups. So where 67% of the calls had to be within, say, 100 meters, and then 90 or 95% somewhere in the 300-meter range. Today, that has evolved where now they are simply just saying, okay, 90% of the calls need to be within 50 meters accuracy and 3 meters vertical accuracy, and that's it. It's just a very simple, because they understand where the technology has evolved to. So and they've kind of been doing this in stages, and this is kind of where we are today here.
Exactly, and obviously we're interacting with probably two of the biggest regulators in the world. One is FCC, and the other one is the EU. Obviously, in conjunction with the European Emergency Number Association team, we are helping to influence what things can be done. Standardization is key, hence why 3GPP has been so powerful in recent years, but being able to establish these standards all around the world so that the software, the services, the hardware will all begin to support this. And that neatly links us to this slide. Sorry for the slight eye chart in the screen here. But what we're looking at really is an evolution and sometimes a revolution in location services technology. Obviously, as an industry, us mobile people, we like to create lots of acronyms. But in the location industry, we go X10 on that. As people complain to me sometimes saying, my God, can you just put it in plain English? The orange boxes that we're highlighting here are some of the key elements. GMLC, the Gateway to Mobile Location Center, it's the orchestrator in a mobile network that will initiate the getting of the location. You may have heard it, may not. It's one of those kind of inside secrets, but it's basically a piece of technology that can be cross-generational. We're at the moment working with some major operators to put in the first, what we call 5G standalone GMLCs. I get those live. Obviously, we've had them in the lab for years, but now they're starting to look to go live. And even that will provide initially level of good accuracy. But really, it's the LMF part. Obviously, you see the other orange box is SAS, is 3G, ESMLC. Obviously, E everything is 4G. And then the LMF is the location management function. Obviously, we like to change the name. So we're going away from SMLC to LMF, the location management function, which will provide the high accuracy orchestration within 5G networks. It takes care of all the new advanced algorithms, some of which we'll talk about today, but it's a key element, again, 3GPP standards, so that these things can have standard interfaces across mobile network vendors. So no matter what vendor it is, the solution should work across those. And the power of that is then, again, what I said originally, following on standardization so that governments, organizations, enterprises, networks can actually say, right, these are standard, we want these out there and we want them prevalent everywhere. So as we said, the other parts as well is, you may have heard the term within 3GP location services architecture. The US like to reinvent names, so they're now going precision location services, which we've heard on various calls with various large US operators. Actually heard it 2 weeks ago from a large UK network operator. GNSS, basically the satellite systems that could be hybrided into this platform, as well as what we're going to talk about a little later on, which is the indoor location and that vertical capability, and the mixtures of what's possible in there. So the 5G location detail is here. the new 5G location management function I talked about. It's key because it interacts with the main AMF in 5G, and the LMF receives the measurements from the network as it interacts with that through the standard NL interfaces, and that basically will allow us to, or allow any service to build up that location information, not just ask for the attached cell of that subscriber, but then I want all of the neighboring cells. I want all of the RF measurements. So I want, you know, this signal strength and many other pieces of data so that we can do all our advanced algorithm that Michael's going to talk about later. But the whole idea really is, again, standardization, that the LMF is a standard 3GPP element, and it will talk standard interfaces. So no matter what equipment vendor you're using, all of this will be functional, and that's the power of having standards. I think that's anything else you want to say here, Michael?
No, that's pretty much it here, and really here this is just to introduce the new radio positioning protocol. That's the orange lines. Those are kind of what are introduced for 5G, and where a lot of the new positioning methods are introduced are in that protocol.
And one thing that we do, and you may have heard me say it, is we live and breathe 3GPP. In particular, one of our senior product architects, she amazes me a lot of the time, mainly because she's in the West Coast at the moment and still doing a call at 1:30 a.m. But she lives and breathes 3GP, talking to the organization, looking to see, you know, not just release 15 or release 16, which had new updates for 5G, but looking forward to release 17 and beyond, and making sure that the standardization is being driven forward, not just for our solution, but for everything. Because basically, the whole power of our message here is that in order for this to work for emergency services, it has to be prevalent. We can't have one operator doing one thing, getting some accuracy capability that's not quite compatible with another one. If I'm an emergency service like UK here, BT999, I want to get a single correlated, accurate, reliable location out of all the networks from the country. And that's the same across the entire world. So standardization is really key. And that's the message we're going to get across here, because all of this is standardized. There's very little. In the original days, we used to have a patented product doing all sorts of what we call RF patterning. And it was very complicated. It helped with 2G, 3G, still helps in various countries. But the power of 4 and now with 5G, these are all standard functions. So we're not having to introduce any kind of custom element into the network, and not having to re-engineer the network in any way.
Yeah, that's correct.
Over to you, Mike.
So, yeah. So the new radio positioning protocol, kind of as mentioned in the previous slide, introduces, and this is just, you know, really points out just kind of 3 of some 9 or 10 additional methods that are being introduced, and each one successively even more accurate. But there's a lot of dependencies on the network, as you know, as the kind of the caveats that Stuart mentioned earlier. But one of the positioning methods we'll talk a little bit about is multi-cell round trip time, and RTT has been introduced in the previous networks. But in 5G, it is significantly more accurate. And part of it also has to do with the type of antennas that are being deployed in 5G, but also just the nature of deployments. You know, these are going to be really microcells primarily. And part of that is, you know, the design also is to, you know, to provide the high data rates that 5G promises, right? But then some of the other positioning methods, angle of arrival and departure, and this is tied very much to the types of antennas that are going to be available in 5G. TDOA obviously is also, it's a carryover, but there's some new methods that are introduced in 5G as well, primarily also because of the precision and the timing available. So this is really, you know, it's about the Z-axis, right? The vertical positioning. You know, these new smart antennas that are going to be deployed in 5G, you know, they have kind of a beamforming technologies you know, they use to serve, you know, they're designed to serve, very tall buildings, so that you can actually now, distribute traffic across the different levels. But that technology allows us also to determine where, in a building, a device is, because you are going to be identified with a specific beam with its own identifier, and with the timing and the angle of arrival or departure from there. It's simple geometry. You can determine now not just the XY, but also the Z axis. And not only that, but even by doing that, the determination of where that device is on the vertical axis, it actually also improves the XY accuracy as well. And again, this is significantly, aided by how the 5G sites are being deployed. The expectations are in 5G is that, we're looking at urban microcellular sites with anywhere between 200 to 500 meter inter-site distance. That adds, that kind of density really improves the way we can calculate location accuracy without relying on AGNSS. That's really the big part, because GNSS has been the gold standard in location accuracy, and it still is, because when it's available, it still gives you the most reliable and accurate positioning method. However, in dense urban environments where you have so much blockage, where you can't really get a good view of the sky, or you've got, heavy concrete around you, you're in a deep underground parking garage, especially a lot of, the high rises that we're talking about, most of the parking is below ground. But, if you are able to receive, 2-3 signals from nearby microcellular sites, this is the kind of location accuracy you can get. This is basically what an open field GPS positioning can give you. So,
and timing is important as well. So we've seen, people may be familiar, may not be familiar with a thing called AML, Advanced Mobile Location, maybe known as other things from Google and from Apple. But basically, it's a standard that's been established mostly here in Europe, I think also in US and other regions, where when you dial, if you have an Android or an Apple phone, an iOS phone, when you dial 112.999, the operating system immediately kicks in to gather the data where that phone is. And obviously it will rely on GPS quite a lot, but that's becoming a challenge because people are worried about their privacy. So the GPS will be sometimes literally switched off or physically switched off. And even the phone can force it on, but it still will take time for it to get those GPS fixes. And then could take anything up to 15 minutes. You might have seen this yourself if you start a phone cold and then you bring up Google Maps. You see that, oh, wait a minute, why is it not working out where I am? It takes a while. Whereas by combining in the network technology, these networks, it has to be connected to a mobile network to be functional. And as long as it can see a few cells, we can generate that first level location. But obviously GPS can be augmented. But what we're finding with the stats coming out of the AML around the world is that its reliability is going down as people, tend to turn off the GPS, even if it's temporary or even if it's accuracy or app wise. It still means that it might have to fire up, and those reliability standards are going down. So hence why this particular thing we're talking about is independent of that. So if I'm in, and again, that was the same when we were talking to the emergency leaders and responder leaders at the European Emergency Number Association, they said, in large built up areas, we cannot rely on it because the signal bounces everywhere. As Michael said, you have large concrete buildings, it'll get absorbed into trees, could even fail in certain areas, in rural areas, but mostly in city areas. So having this technology will give you GPS level accuracy, but it will do it more reliably. And that's the key. We were involved in an audit in a Latin American country where they had significant problems given their geography in being able to obtain reliable accuracy. And they set us a challenge, an audit challenge. can we meet reliability exceeding 90% at some levels? And we didn't just match it, we beat it, which meant that they were able to offer literally 100% guarantee that some form of location on an emergency call will be provided, whether it's got from GPS, whether it's got from Wi-Fi, whether it's got from the network. Our location engine basically works out what's available, what's reliable, and then provide that in real time to the PSAP. Sorry, Michael, go ahead.
No, not at all. Thanks, Stuart. And you know, really from a public safety standpoint, this is very critical. You know, this is and you know, these are cases that have actually occurred here, even in the US, where you know, a caller will make an emergency call, and you know, they can locate that caller using AGNSS while that call is active. But what typically happens is if that call is terminated for whatever reason, you know, maybe the call dropped, or you know, the caller is in a critical condition, the public safety answering point has maybe just a few seconds after that call is terminated to still use AGNSS to locate that device. After a while, typically a lot of the devices, especially you know, if it's an iOS device or you know, some Android devices, will not allow you to use AGNSS outside of an emergency call situation. So now you are falling back to the network to locate that device. And you know, where maybe 2 minutes ago you were able to locate that device with high precision, now you're falling back to a network, you know, that's potentially maybe only even cell ID. And now you have no idea where that caller is anymore, if that caller was in motion at the time. So these kind of positioning methods are going to play a critical role in public safety moving forward.
They're going to save lives. I'm having been working in this field for so long, and then obviously meeting with emergency responders and at many different levels. You know, if governments take this seriously, it will save lives. It will take time. It's not going to pop out immediately, but it will absolutely save lives. I have no doubt in that, for the conversation that we have today and what will happen in the future.
Yeah. And that's really kind of, you know, this is from a public safety standpoint, this is where it's, you know, 5G is going to bring, you know, a very, you know, high degree of reliability and you know, precision positioning for the first responders, which is very important. In addition, not just in locating the you know, the emergency caller, but it is also now being used to track and direct those first responders, especially when they're you know, if they're, you know, battling fire inside a high rise, to be able to direct them to the correct areas and understand where the first responders are, so that if they are in trouble, they can send aid to them as well. So this is, you know, 5G is going to bring, you know, huge benefits to all aspects of public safety. And especially, you know, one of the things that, you know, kind of we wanted to stress here is that, you know, while AGNSS is still the gold standard for accuracy, you know, and just by nature of where people live today, it's, you know, when it's not available, it's not available. And so you have to rely on the network for positioning. So and really what 5G does is it just reduces that dependency. You know, you know, we still believe in AGNSS, and especially with the addition of new constellations, you know, it becomes an overdetermined solution. So the accuracy of AGNSS has been improving, but you know, again, until the signals get strong enough to penetrate some, you know, some buildings, you still have to have a reliable fallback.
Absolutely. So, you know, obviously we're not going into detail on the vertical, but I presented at the ENA conference about vertical alongside Google and Apple and Esri, the 3D map people. And, you know, some of the things that we discussed, you know, around the vertical challenges, which 5G will help with, is, you know, Currently, and it's just been tested in the US, they rely on barometric pressure. So, I asked the audience, I said, did you know your phone, a lot of phones today, quite a high priority of them, a high majority of them, actually have a barometric pressure built into the phone, and it can actually take the pressure sense from and actually feed that in to try and give an estimate of where you are. Challenges with our large buildings these days, you're sitting near an elevator or you're sitting near the window, you're going to get different barometric levels. So with 5G, that can be cross-referenced. What we're looking at is combining everything. Combine the ability of the handset to have barometric pressure. The improvements with 5G, I think, will absolutely transform it, because there's a lot of additional information we can get, as well as the improvements in AGNS and new satellite services, as well as other techniques such as beacons and also Wi-Fi. One of the biggest problems at the moment around location, and it's that bringing together of small 5G nodes and Wi-Fi networks, obviously near the two shall meet, but being able to use all of that in order to be able to come up with the most reliable location that you possibly can is going to transform this. We really want to get people talking about it. So that's really what I want to do every time Michael and I do these presentations all around the world. We just want to get people to start talking about it so that governments and operators and commercial businesses can start planning it. Already, I know commercial businesses are trying to plan for 5G, but 5G will transform all of that. Most of what we've been talking about today has been on emergency services, but it's the same for law enforcement, and it's really big for commercial services. I think now we're going to go to questions that we have. Sorry, Michael.
Yeah, no, and actually, I think we have a couple of great questions here as well, and I think we may have addressed one, but I know, so one question that we had here is this technology dependent on GPS, and what happens if we lose GPS for some reason? And that's exactly kind of what we addressed there right at the end, right? It's not dependent on GPS. It's actually, this is just purely network-based positioning that we are discussing. Obviously, GPS positioning.
I think the question was asked a long time before that. So
yeah,
I see. Okay, right. Yeah.
To answer it straight, it's not dependent on GPS. It can produce a location without any access to any GPS signal or any GPS data.
Yeah.
Okay, correct. And then your next question is, in which 3GPP release these new 5G functionalities become really available to the industry?
Excellent question.
Yeah. So pretty much release 15 on. Release 16 actually included a lot of the positioning methods that we talked about, and those are already ratified and available to all the infrastructure vendors.
Yeah. So what you'll find. Sorry, go ahead. Yeah. What you'll find is that, these were obviously initially, because what happens with 3GPP is they put out the feelers for these things, and that would have been release 15, which is pretty well locked in and established at this point for a while. There will be improvements. Again, I'd love to have my colleague here who lives and breathes the 3GPP standards, but there's improvements, obviously, which is in release 16. Which really kind of locked all of that in. But again, release 17 will have, again, new functions, updates, and new parts of it. So the answer to your question is they're really kind of available today, but it depends on what your use case is. But to answer that as straight as we can, if you're on the latest release 16, I don't think 17's out yet, you should start seeing these, but talk to your network equipment provider.
Okay, and then here we go with some abbreviations. So do you see LMF as an essential CNF in any new 5GC deployment?
Oh my God. I separate the two, even though 5G from a network perspective really has taken the whole containerization. So that's CNF, that is the way forward, the container network function. What it is to have these small pods of easy, reusable, portable components within your network, of which LMF would be one of them. It's not necessarily. We've actually deployed LMF separate, just as a virtual machine within 5G deployments. But I think your thinking is right. What we find with a lot of operators, OpCos and MNOs and TOs and ISPs is that they are really doing all their 5G within containerized environments. So they're not dependent on each other, but you're absolutely right. We do see them together. They're not essential. So the LMF is a function that just people now want to go towards the containerized future. And when they term that, that's what they want. And basically we can deploy it as both, and we have. Michael, your terms?
Yeah, so I think you answered this one perfect, because you know, the LMF, one, it's going to be dependent on if the carrier has that requirement to deploy it, and then two, it just depends on how they've deployed their 5G network. But the LMF can be deployed either in a CNF environment or in some other virtual. In a
virtual, or even one customer just in their lab put it on bare metal. They just put it on a Red Hat Linux server. So it's just a software module that we can deploy along with everything else, and many other vendors as well.
Yeah.
Okay, and next up, is there any impact in the 5G device side to use all these improvements for location in 5G? So does all this stuff affect the device?
Yeah, maybe I'll answer that in part, and then Stuart, maybe I'll let you add to this. So it's a yes and no answer, in that there are going to be some dependencies on the device, because you know we talked about one method here. There's several new methods that are introduced. Actually, some also carry over from 4G, but you know, say one of which is using a terrestrial beacon system. Or barometric methods, barometric pressure sensors on the device. So if the device has, you know, these capabilities, those are also used to calculate the vertical positioning. But if not, then it's the on the network side, right? Like the kind of antennas that we talked about, have they been deployed? You know, then if so, then those are, you know, we typically just rely on the network. So it's a combination.
Yeah.
So and the goal is to not rely on any one method, and to use as many as possible, whether it's, you know, measurements from the device or from the network.
Exactly. I think for the boiling it down, you know, you say, is there any impact on the device, on the 5G device? If we're just doing what we call a network locate, the whole idea is there should be no impact on the device, because we're gathering all the data. We don't interrogate the device as a general principle. You do when you're using AG and SS, you're asking the phone, get me your GPS signal. But from what we've been talking about, which is deriving the location from the network, it means we don't query the device in general. There are exceptions, but in general, we don't impact on the device, which is key. It's key from the point of view of an emergency services. If that device is kind of broken in any way, that apps aren't working or something else isn't working, as long as it is connected to the network, we will be able to get its location. We're not asking it for a GPS signal. We're not asking it to tell us what micro networks it's connected to. We're just generating the data from RF, from network statistics, and doing that in real time. Yeah. Hope that makes sense.
Now, sorry, Annie, in emergency services, when basically, or in an emergency call, when the device is making all its capabilities available to the network, right, it will broadcast what it can do. And based on that, the LMF can ask the device to provide, give me your barometric readings, give me your, you know, do you detect terrestrial beacon systems, give me those measurements. So it can take all that and calculate a position using those methods. So it's, the device will broadcast its capabilities, and the LMF will respond accordingly.
If appropriate, but if again, at its rawest form, it doesn't need the device to do anything other than be connected to the network, which gives emergency services a lot of confidence, because you don't know what kind of feature phone you're accessing. You don't know what it has switched on, switched off, whether it's software, whether it's physical switches, purely at its real pure level. And people love this, from law enforcement to some commercial services from an anonymization perspective. We do not need to do, at its rawest form, do anything with the device. But as Michael said, and I said, you can augment it by querying the device directly.
Okay, so 2 questions now, which are good because the things I wanted to ask too, or they touch on them. So One is, what are the technical parts in 5G that provides this increase in accuracy? And is smaller cell sites one of them? I wanted to talk to you about small cells actually and indoors, but anyway.
Well, it is related to the next question as well about Wi-Fi based location.
Yeah, I was going to ask you that too, as you know.
So just stepping back for a moment, what's important from a network location perspective is what we call cell density. How close are all the mobile cells to each other, and what can they see? So that if we have a lot of smaller cells, as long as I as a mobile phone can see all those cells, and that's stored in the network, we can actually get it. So the smaller cells, we'd imply more cells, but also remember that the kind of cone, the pizza slice shape will be smaller with a smaller cell, which means that gives us confidence in the smaller area. And then if you have two smaller areas intersecting, and sometimes we look at 5 intersections in order to get some of the really high accuracy we need, it will really help. So remember, it's about not just the size of the cell, which does help, absolutely does. So what area does it broadcast to, and also what's the density in that area? So we tend to put it into 3 categories. There's ultra dense urban, there's suburban, and then there's rural. But all of the cell, if it's a small cell, it will, as long as we can see that cell, we've got the information on it, and you know you're in it, we can actually identify it. But the cell density, how many neighboring cells, because remember, you will be attached to a cell, depending on how your movement is, but then you'll also have what we call neighboring cells, and that's key for high accuracy. So I hope that helps. Linking that down to the Wi-Fi based fit into the picture. Wi-Fi is used for emergency services. So when you dial your 112, your 999 or 911, that AML service, so within the Google operating system or Android or within iOS, Apple, it will actually reach out and say, right, what Wi-Fi nodes can I see? And then there is like an open source database of where all those Wi-Fi nodes are, and it provides the location. That's at an absolute base level. That's kind of being transformed now with 5G, because the small cells, sometimes they like to have both small cells, which would be like 5G, but it might also be attached to a tower that's also doing Wi-Fi. And this could be for a stadium example, it could be for a station example, it could be many, and it depends on the operator. But what we're talking about today is very much deriving the location from the mobile network, but the blurred lines, obviously Wi-Fi is very much a standard. Obviously now they come with the big networks. We can do things like multilateration with Wi-Fi networks, but because you don't have the level of standardization, I know I keep going on about this, because you don't have the level of standardization, I know it's changing with Wi-Fi. There isn't the 3GPP in Wi-Fi, there is some of it, but not as prevalent as you imagine. You could have all sorts of Wi-Fi devices coming from all sorts of vendors. It is starting to come together, but we're really, really early days on that.